So we're going to continue with Excel, get a little more complicated. The equations will get a little deeper, not much, but they do use trigonometry. So if you've not had trig, that's a problem. So I'm going to do a quick trig review, and then I'm going to show you some things in Excel, and then I'll cut you loose. So the project is to create a spreadsheet that has multiple sheets. So if you don't know what that means, I'll show you that, but it says create a 4-sheet workbook that does the following. So it's one file, but you can add sheets in Excel. Okay. And then the sheets can interact with each other. So you can pull information from one sheet to another sheet to a final sheet that sums things up. So sheet 1, 2, and 3 is going to be calculating the angles, sides, and area of a right triangle. So that's the one where I probably need to cover a little trigonometry, at least refresh your trigonometry. And then a trapezoid on another one, and then another right triangle, which you should be able to use the first right triangle to set up the second one. So it's not like you have to create all three. Probably got to create 2 though. And then the fourth one is going to be just adding up areas. So that's where you'll have to pull from cells from different sheets to add up the areas. I don't want you to recalculate the areas. All right, so in Excel, I've started one here, and I'm in the view page layout because we want to kind of set up like homework. So what I did was put my name, course number, date in the header. So then it'll show up on all the other pages, right? But there's only one page in this sheet that you're going to use. You're going to set up the triangle. And then this little plus is to add a sheet. So here's where the trapezoid would go, right? And then here's where another, I just added again, sheet 3. This is where another triangle would go. And then sheet 4, adding up the areas. You can name these. So you should be able to right click on it and name it. Triangle 1, right? Rename. Trapezoid, triangle 2, sum of areas, right? You can name the sheets. All right. So let's talk a little bit about, since we have to do all the angles, all the sides of a triangle, I made it a right triangle, so we don't have any cosine law, sine law stuff, right? It's just sine, cosine, and tangent. And you can probably get away with just sine and cosine, but I'll leave it up to you. But what we have to be able to do is calculate these angles, right? And these sides of a right triangle. Has everyone had trigonometry? Yeah? So this, no trigonometry. Okay. So I'm going to go through it. A right triangle has a 90, right? And that's the one that we're going to work with. The things we can use, sine, cosine, tangent, and also there's information about the sum of the 3 angles. Anyone remember what that is? They all add up to 180. So the sum of the angles equals 180 degrees. So if you find one of these, right, we know this one's 90. You can get that third angle by the subtraction of 180 minus the other 2. So that's a good strategy. Typical labeling. A, B, I'm going to put a little tail on that C. A and B can be either side. C typically is the hypotenuse. Okay. Notice it's small case for the sides, and then it would be large caps for the angles, and it's angle opposite. So this would be B, This would be A. This would be C, but we already know that as 90 degrees. So that's just a standard way of labeling. You should use that probably, since you're going to create these triangles yourself. I mean, you could make it a little more fun, I guess, and put, you know, miles in or feet or some kind of a unit. But yeah, label it definitely. So with a triangle, you need to know some information. You can't just leave it all blank and hope to solve it, right? So you're going to have to give yourself some starting information. All right. So if we know maybe side A is 11 inches and side B is, I'll make it a little shorter, 10 inches. Right? We know two sides, that's enough information to get everything. If you know two pieces of information, could be an angle in a side. It could be, I don't think it could be two angles. I think we need a side in there. Yeah, so you got to have a side in there, right? All right, so you got to give yourself two pieces of information. Make those inputs, right? So you could then change it. Any triangle would work then. Any right triangle you'd be able to solve with your little spreadsheet. So let's just do a little trigonometry. These are for the angles. So sine, cosine, and tangent help us find the angles. Sine of an angle, and I'm just going to put theta in as a holder, is equal, anybody remember what this is? Sine is equal to opposite over hypotenuse. So there's some sayings you can memorize if you want, SOHCAHTOA or something like that, right? To keep these straight, or just look them up. I don't care. But the way this works is it's very dependent on where that angle is. It's not always the same. Depending on the angle you're going to use, this is the opposite side of that angle. So if A is my angle, what is the opposite side of angle A? It's side A, 11 inches, right? But if B is my angle, the sine of B, the opposite side is 10 inches. So the big problem that folks that haven't used trigonometry a lot is they always try to do the same thing with sine, like always use that lower right angle. Well, you can't. Sometimes you have to use some other angle and just set up what's opposite and what's hypotenuse. This is always hypotenuse, that long side of a right triangle. Okay, so if we wanted A, like if I want to know this, I would use this because I know opposite is 11 inches. Uh-oh, I don't know C. So what I want is this to be solved, and then that becomes my unknown angle, right? So these two, you got to know to use it. Well, let's look at another one. Let's look at cosine. Anyone remember cosine? Adjacent over to hypotenuse, same problem. We don't know C. So we can't use this to get A. Right? Well, there's one more, and it's called tangent. And what's that one? All right, so I'm going to actually write in tangent A. We're doing a little trigonometry review because you use it in Excel today. So tangent A. So I just subbed in the angle that I want. Tangent A. Opposite is 11. Yeah? Everyone with me? You're either with me or you're against me, and you want to be with me. All right. Adjacent. What's the adjacent side to A? Yeah, it's 10 inches because this is always opposite. I mean, hypotenuse. This is always hypotenuse. It never opposite or adjacent, right? Always hypotenuse. So yeah, it's 10. So that sets up tangent A equals 11 over 10. How do we get the angle by itself? You might want a little more than you plug it in. Yeah, so you do use the inverse of tangent, but why does that work? Algebra is why that works. If I want to isolate A all by itself, what do I have to do to get rid of tangent? I have to divide by tangent. Right? Everyone agree? Basic algebra. That means what I do to one side, I have to do to the other side. So that means I have 1 over tangent there, which is the inverse tangent or arctangent. Most calculators have either tangent to the -1 or what I have is a tangent. It's in blue right there. Arctangent. Right? Some calculators will have tangent to the -1. So the way this works, because now A is by itself, this will be the angle, A equals, and it's typically written tangent to the -1 or arctangent, 11 over 10. So all three of these functions work the same way for finding the angle. You have to isolate the angle, you'll end up doing the inverse of whatever function you're using, right? So when I run this, (11, 10) arctangent 47.726 degrees. Good. Then of course, we want to think about it and say, oh, does that make sense? Yeah. If this was 11 and 11, what would the angle be? 45. So since it's 11 and 10, 47 makes sense. It's close to 45, but not 45, right? Very handy that my calculator is set to degrees mode, not radians, right? So I get degrees, but guess what? Excel is set to radians. So it's going to pump out radians when you do this stuff. There is a conversion. It's called degrees. And degrees turns radians to degrees, right? So I recommend you do it in pieces, and I'm going to show you that in Excel. Now, that was a super quick, really basic review of trig, right triangle trig. Maybe enough for you, might not be, so just get my help or get somebody's help with more of it. You still got to put the formula in. So, all right. So let's look at Excel and kind of how it works in here. I'm going to zoom this up a little bit. So I got one set up, right? You're going to do a triangle. You're going to give yourself enough information. So I gave myself this. Let's see. I think I have the same shading system where, oops, I don't want the text. I want actually, no, let's not do that. I want shading. Where input's green. So do that for me. And then anything calculated becomes red. So I gave myself the two sides, right? You will have to give yourself two pieces of information. I gave myself units, inches, and then I ran the square root, right? So that's the kind of thing I want to see you doing, is playing with these formulas and figuring out how to make this thing pump out information. So anytime you want to do something, you can, like for the square root thing, I just started with equals and then I typed in SQ and it came up square root, right? And then it explains to you what it does. Returns the square root of a number. Okay, so then I hit 2 clicks, click, click. I know the format is square root, bracket, bracket. So I got to get something inside the bracket, right? So what I did was grab that cell, used caret, and sent it to the second power. So I'm squaring the first, squaring the second. I'm going to add this one to it, and I'm going to square it, right? And then I need to close my bracket. So now the square root's going to do the square root of that action. I would be using my calculator to verify that it's working for sure on all this. All right, hit enter and I get my number. Okay, that's how I got this. Good. Then I said, okay, well, I need to find this angle A. So I could do it with sine because I know opposite and hypotenuse. I could do it with cosine, right? Because I know adjacent and hypotenuse. And I could do it with tangent. I can do it with any of them. And I don't care which one you do, right? Do whatever one you want. Go for it. Let's see what I did. Looks like I used the sine, right? And I put it in this form. I figured it out first, what the equation needed to be on my scratch paper. But then I just went for putting it in. So it's taking, so if you click on this up here, oh, you can see the boxes it uses. It's kind of fun. If you click on the formula, it'll color code the boxes it's using. It's super handy. So it's kind of hard to see, but A10 is blue and this is blue. And F9 is red and this red box is here. So that's the two cells it's using for the equation. And this is kind of how I look at yours, is I just click on the formula and go down and see, oh, what they're doing, right? So it's going to take the arc sine of A10 divided by, so it's opposite over adjacent. That's why it's using sine. Okay. Again, I would use my calculator to verify this number. The problem with that is Excel gives you radians. Excel thinks in radians. Okay. And I made a note of that. But what I would encourage you to do is not do, I mean, you can make it give you degrees by putting the degree function in front of this whole thing. But that's a little bit of bracket work and it gets kind of complicated. So what I did was here, I just used the degrees bracket. And what that does is it converts radians to degrees. Okay. Now it could be here. In other words, I could go up here and I should be able to go degrees, bracket, and do it all in one move. It did it. It messed this one up, right? Because it's using the number above, but it did it. And then this would say degrees. So if you just wanted a one-step thing, you can make it do it just by putting the degrees in front of any radians you're given. That make sense?
Will we turn the degrees and radians into like, will we like make it red like those boxes or just the degrees?
If it's a calculation, make it red. Yeah, so both of them. Yeah. So I'm okay. What I would say is if it's not working, whatever the formula is, break it up. Break it into small pieces in multiple cells and then combine the cells again in another equation just to figure out what's going wrong. And then like I just did, you can go up and edit the equation. So this is not here. I'll make it revert back to. So there's one called radians. And it should take that and turn it back into radians. Yeah. Okay. Not that we want that, we don't. But just to show you the two, they're just converters. Going to take any radian, convert it to degrees. You can take any degrees, convert it to radians. Right? And again, the reason we do it, getting rid of this, is we can come in here and put in any number we want, right? And now this is just a triangle creator. It's going for
supposed to be angle B or angle A?
angle A is here, right? And that's
oh, sorry.
that's its angle A.
Okay.
This is angle B up here.
Okay.
Yeah. So remember, if this is side B, that's opposite's got to be angle B. That's kind of the notation. side A, opposite's gotta be angle A. Yeah, this could be a lot closer to the actual angle.
You just solve, both things, or just one?
Everything,
Okay.
all parts of the triangle. So all three sides, all three angles. All right, one angle is already 90. You don't have to solve that one. Right?
There are ones easier because you can just add those two.
Yeah, absolutely. Like now that I have this angle, I could write my equation for angle B. Is that gonna muck it up? It kind of drags your shapes around a little. I hate that. But that's all right, you can fix it. Equals, so this could be, whoops. Man, if you put something in with that equal sign, it starts to freak out. This could be just the manipulation of the angles, right? 180. So this could be equals 180. That's a constant. I don't have to put that in a cell and use a cell location. It's always 180 minus that, right? Minus that. And angle B gets pumped out, right? And the shading's important because when you come in, you're going to want to know, like, what can I input, right? Where can I input? Because you can't input here. That's not going to work. You pump a number in here like 40 and it just screws that up. It takes your equation out, right? So they can only be run a certain way. The more equations, the better. Like this is a triangle that solves all parts of the triangle given two sides, right? Your other triangle that you're going to make, because you're going to do two triangles, make it maybe import the hypotenuse and one angle, and it'll pump everything else out, right? That's the point. And then you got to do a trapezoid. Good luck with that. Questions? In the end, you're going to sum it all. So like in sheet 4, it's going to sum all the areas, right? So if I have, I'm going to just say sum of numbers and show you how this works. And I'll put in equals. And then I will, justify it, right? And I'll go to, I don't know why I'm over there. I'll put it over here somewhere. I'm going to go to view page layout so I can kind of see it here. Still not where I want it. Is it here? Oh, I justified it. All right. So here I can go equals, and then I can travel to the sheet and choose what I want. So I can travel here and choose that. Right? See what it's doing? It's doing the equation right here, but that is sitting on a different sheet. That's sitting on sheet 4. Does that make sense? And it kind of tells you that it's coming from triangle 1 sheet. That's the name of the sheet, and it's A10. And I can add to it. Whoops. If I had something here, I'll put something. Oh yeah, I could add to it that cell. I don't have anything in that cell, but if there was something there, right, it would add to it. What cell is that? D10. Let's see if it takes it here. Yeah, it did it. It's just D10 is empty from the trapezoid sheet. So you do want to name your sheets. It's very helpful. So I'll put a number in here, 20. So now it'll pick that number up and it's summing it for me. So the formula looks like equals the cell location refers to the sheet. So that is A10 from sheet triangle 1 because I named my sheets. And this is D10 from trapezoid. That's that sheet, right? So it'll do it. You can pull information from different sheets, and that's what you're supposed to do with sheet 4 is add up the areas that you're calculating for each one of these shapes. Sense? All right, so you have a triangle, a trapezoid, and another triangle. This should say triangle 2. Obviously, you don't want to just call it triangle both times because these sheets need to be independently named. Questions? All right. Very good luck to you. When's it due? The 18th. So you have time. Oh, let's read through it all. For each output, you should be creating equations. Shade those green. For each input, shade those red. That's what I just did, I think. Yeah. Set up each sheet like a homework problem. Name, date, class, blah, blah, blah. So that's kind of what I mean by that is like this, right? Get yourself in. Oh, this thing's in my way. Go away. Go. Hide. It's not gonna hide. If you're in page view, then you kind of see what it looks like. And then when you go to, which I encourage all of you to do, just go to print and you'll see what it's going to look like. Right? And you can see if you use the headers, they pop up there nicely. Kind of a good thing. All right, that's it. Go for it.